Welcome ladies and gentlemen to Warwick Sciences Film Practicals, and this one's on the property of gases. As usual, there is an experiment write-up, so what I would like you to do please is once it comes onto the screen, could you please copy it down? You can pause the video to do that, copy it down, and then when you're ready to go, restart the video again. Okay, now what you can see I have here is I have a simple balloon that's been inflated only a reasonably small amount, and it's over the top of a conical flask. So this is what we call a closed system. There's no way that air can get into and out of the conical flask and or the balloon. So any changes to the shape of the balloons is not due to air leaving or air coming in. It'll be due to one of the properties of gases. Now what I need to do and what needs to be put into your table is I need to measure that, so I'm just going to put it around the middle of the balloon, and what I've got there is I've got 30 centimeters. So the circumference of the balloon at room temperature is 30. Now I'm going to do two things with it. The first thing that I'm going to do is I'm going to put it into some ice water to cool it down. Okay. So we'll just mainly just ice, I think I will go with. What we'll do is we'll make sure that we surround it. Once again, another one of those messy sort of practicals that we get into here. Okay, so we will just place it in there, and then what we'll do is we'll wait a degree of time. We'll wait a couple of minutes, and then what I'll do after that is I'll then measure the circumference of the balloon again, remembering it was 30 to start with, so we'll just wait a short while that does its job. Okay, that's been about 5 minutes now, so what we'll do is we'll just leave it in there for a moment, and we'll basically take another measurement again around the same location. So we're measuring the circumference, and this time we get to 28 centimeters. So it's obviously at the cold icy water, it is 28 centimeters. Now what we'll do with this is we'll take it out. Okay, we'll basically brush off the ice. Okay, just warm that a little bit because we're going to be transferring it into a beaker of hot water, and what we don't want to do is have it very cold and then put in hot water, because that will break it. So just warm that up a little bit. That should be fairly good, and then what I'll do is pour in some hot water here from the kettle. Now this was just recently boiled. Okay, now of course it's going to basically float because it's filled up with air. So what I will do is I'll get one of the pieces of our science equipment that we have, and I'll basically hold it under there. Now again, I'll do the same deal. I'll wait for a length of time, around about 5 minutes. That's the same as the other one, and then after that time I will basically measure to see the effect of putting the sealed system into hot water. Okay, that's been about 5 minutes, so what I'll do is I'll take that out now. Okay, and we'll re-measure the balloon, this time under hot water. And I can see it appears to be a little bit larger. It'd be interesting to see how much it is. And we get up to 33, no, it's just still right around the bottom, no, 32.5 centimeters. So it has increased from the original room temperature from 30 up to 32.5. Now of course, when answering this particular prac in terms of its outcomes and working out what's going on, a couple of things that we need to remember. Number one, we didn't add any air, or air wasn't removed from the system. It's a closed system. Okay, so what you will need to do is try to use the particle theory and the 4 points of the particle theory to explain what's going on here, because obviously we need to have a look at what happens when we put the air that's inside here into hot or cold water. Once you've done that, please check with your teacher to make sure that you have everything correct, and thank you very much for accessing Warwick Science's Film Practical of Properties of Gases.